In the summer of 1980, a reconnaissance satellite passing over the Leningrad shipyard captured an image that would send shockwaves through the corridors of the Pentagon. There, sitting in the cold waters of the Baltic Sea, was a vessel unlike anything the Western world had ever seen. At 252 meters in length, displacing over 28,000 tons at full load, the warship designated by NATO as Balkan 1 represented a quantum leap in Soviet naval power. This was the Kirov, the lead ship of what would become the most heavily armed surface combatant ever constructed by any nation. When American analysts finally completed their assessment of her weapon systems, they reached a conclusion that seemed almost impossible to believe. This single vessel carried more firepower than an entire NATO surface action group. The numbers were staggering, unprecedented in the history of naval warfare. This is the story of how the Soviet Union built the most terrifying warship of the Cold War, and how Western intelligence scrambled to understand a threat that redefined the meaning of naval supremacy. If you find this journey through Cold War history fascinating, please take a moment to hit that subscribe button and give this video a like. Your support helps us continue bringing you these incredible stories of military history and the technology that shaped our world. The origins of the Kirov class can be traced back to the late 1960s, when Soviet naval strategists faced an uncomfortable reality. The United States Navy, with its massive carrier strike groups, dominated the world's oceans. American aircraft carriers could project power anywhere on the globe, and Soviet attempts to counter this capability with conventional surface ships had proven inadequate. The Kinda and Kresta class cruisers, while capable vessels, simply could not threaten American carriers operating under the protective umbrella of their air wings. The solution, according to Admiral Sergei Gorshkov, the architect of Soviet naval power, was to create something entirely new, a surface combatant that could operate independently, strike American carriers from extreme range, and survive the withering counterattack that would inevitably follow. This would require a ship of unprecedented size and capability, armed with weapons that could overwhelm the most sophisticated defenses in existence. Admiral Gorshkov had spent decades building the Soviet Navy from a coastal defense force into a blue water fleet capable of challenging American supremacy. He understood that the Soviet Union could never match the United States carrier for carrier, but he believed that different approaches could achieve similar strategic effects. The concept that would eventually produce the Kirov reflected this thinking. Rather than attempting to replicate American naval architecture, Soviet designers would create something uniquely suited to their strategic requirements. The result would be a ship optimized for a single purpose, destroying American aircraft carriers and the threat they represented to the Soviet homeland. The project that would eventually produce the Kirov began in 1968 at the Nevsky Design Bureau in Leningrad. The initial concept called for a nuclear-powered guided missile cruiser of approximately 15,000 tons, armed with the latest anti-ship missiles and capable of independent operations far from Soviet bases. But as the design evolved over the following years, the ship grew larger and more capable. Engineers added layer upon layer of weapon systems, each designed to address a specific threat or fulfill a particular mission requirement. The air defense suite expanded from a single system to multiple overlapping layers. Anti-submarine weapons were added to protect the ship from underwater attack. The propulsion plant was upgraded to provide greater speed and endurance. By the time the final plans were approved in 1973, the resulting vessel was so large and so heavily armed that NATO analysts struggled to classify her. The Nevsky Design Bureau, led by chief designer Boris Israilovich Kupenskov, faced unprecedented challenges in integrating so many weapon systems onto a single platform. The ship's electronics alone presented immense difficulties, as the various radars and sensors had to operate simultaneously without interfering with each other. The power requirements were enormous, exceeding anything previously attempted on a surface combatant. Weight distribution had to be carefully calculated to maintain stability while accommodating the massive missile launchers and their associated magazines. Kupenskov and his team worked for years to solve these problems, developing innovative solutions that pushed the boundaries of naval engineering. The ship that emerged from their efforts was not quite a cruiser, not quite a battleship, and not quite anything that had ever sailed before. The designation chosen was battlecruiser, a term that had not been used since the Second World War. Construction of the first hull began in 1974 at the Baltic shipyard in Leningrad, the same facility that had built warships for the Russian and Soviet navies for over a century. The yard had constructed everything from pre-revolutionary battleships to modern nuclear submarines, but nothing had prepared them for the scale and complexity of Project 1144, as the Kirov class was known internally. The ship's massive hull required new construction techniques and specialized equipment that had to be developed specifically for the project. Thousands of workers labored on the vessel, their efforts coordinated by managers who understood that any delay would reflect poorly on the entire Soviet shipbuilding industry. The project was shrouded in secrecy, with elaborate measures taken to prevent Western intelligence from gathering information about the ship's true capabilities. Workers at the Baltic shipyard were forbidden from discussing the project with anyone outside the yard, even family members. Security personnel monitored the facility around the clock, watching for any signs of espionage or unauthorized information sharing. The hull was covered with camouflage netting to obscure its dimensions from reconnaissance satellites that Western intelligence agencies were known to operate. Despite these precautions, American intelligence was aware that something significant was under construction. Satellite imagery showed a vessel of unprecedented size taking shape on the buildingways, and signals intelligence detected references to a new class of capital ship in Soviet naval communications. The challenge for Western analysts was determining exactly what capabilities this new ship would possess. The Central Intelligence Agency established a dedicated team to monitor the Kirov's construction and assess her potential capabilities. These analysts examined every available piece of information, from satellite photographs to intercepted communications, to reports from agents operating within the Soviet Union. They studied the equipment being delivered to the shipyard, noting the types of radars and weapon systems that were being installed. They analyzed the ship's dimensions and tried to estimate how many missiles she could carry based on the size of her deck structures. The picture that emerged was fragmentary but alarming. Whatever the Soviets were building, it was clearly something out of the ordinary. The Kirov was launched in December 1977, sliding into the frigid waters of the Neva River before a crowd of shipyard workers and naval officials. The ceremony was a moment of pride for the Soviet Union, proof that their shipbuilding industry could produce vessels that rivaled or exceeded anything in Western inventories. Even then, her true capabilities remained hidden. Western observers noted her unusual superstructure and the large radomes that crowned her mast. But the weapon systems themselves were largely concealed behind hatches and covers. The vertical launch silos that housed her surface-to-air missiles were flush with the deck, their presence detectable only by the slight rectangular outlines visible from above. The massive hatches covering her anti-ship missile launchers were kept firmly closed, revealing nothing of the devastating firepower that lay beneath. It would take another 3 years of fitting out and sea trials before the ship was ready to join the Soviet fleet. During this period, the Kirov underwent extensive testing of her propulsion plant, weapon systems, and sensors. Soviet engineers discovered numerous problems that required modification, as was typical for such a complex first-of-class vessel. The nuclear reactors required adjustments to achieve their designed power output. The radar systems needed calibration to meet specification. The weapon systems had to be integrated with the command and control systems that would direct them in combat. Each problem was methodically addressed, the solutions documented for application to subsequent ships of the class. By late 1980, the Kirov was finally ready for operational service. She was commissioned on December 30, 1980, and immediately began a series of exercises designed to demonstrate her capabilities to both friend and foe alike. Soviet naval commanders sent the Kirov into the Atlantic, where she would inevitably be observed by NATO reconnaissance aircraft and ships. The message was clear. The Soviet Union had created a warship that could challenge American naval dominance, and they wanted the world to know it. Western intelligence agencies scrambled to collect as much information as possible about this new threat, deploying every available asset to observe the Kirov's operations and assess her capabilities. The reaction in Washington was immediate and intense. The Office of Naval Intelligence had been tracking the Kirov's construction for years, but seeing the completed vessel in action was something else entirely. Photographs taken by reconnaissance aircraft and ships showed a warship bristling with weapons, her decks crowded with missile launchers and gun mounts. The sheer density of armament was staggering, far exceeding anything in the American or NATO inventory. Intelligence analysts began the painstaking process of cataloging every visible system, cross-referencing their observations with intercepted communications and agent reports from within the Soviet Union. The task was enormous, requiring the efforts of hundreds of specialists working in facilities across the United States and Europe. The centerpiece of the Kirov's offensive power was the P-700 Granite missile system designated SSN-19 Shipwreck by NATO. 20 of these massive weapons were carried in fixed launchers beneath the forward deck, arranged in 2 rows of 10 angled outward at 35 degrees from the center line. Each launcher was a substantial structure in itself, designed to withstand the tremendous forces generated when a 7-ton missile was hurled into the sky by its rocket booster. The missiles were loaded in port using specialized equipment, a process that took several days for a full complement. Once loaded, they could remain in their tubes indefinitely, ready for launch on command from the ship's Combat Information Center. Each Granite missile weighed over 7,000 kilograms and measured roughly 10 meters in length. dimensions that dwarfed any anti-ship missile in the Western arsenal. The weapon was powered by a turbojet engine that propelled it at speeds exceeding Mach 2.5, too fast for most air defense systems to engage effectively. Its guidance system was among the most sophisticated ever developed by the Soviet Union, featuring both active radar homing and a complex target discrimination capability that allowed it to identify the highest value target in an enemy formation. The seeker head could distinguish between different types of ships based on their radar signatures, selecting aircraft carriers or command ships in preference to escorts. The Granite's warhead was equally impressive. Weighing 750 kilograms, it was designed to penetrate the armored flight deck of an American aircraft carrier and detonate inside the hangar bay, where fuel and munitions would turn a single hit into a catastrophic conflagration. Some missiles were reportedly capable of carrying nuclear warheads with yields of up to 500 kilotons, though this was never officially confirmed by Soviet or Russian authorities. The prospect of a nuclear-armed anti-ship missile was particularly troubling to Western planners, as it suggested that the Soviets might escalate to nuclear weapons at sea even if the conflict on land remained conventional. But the true genius of the Granite system lay in its cooperative attack logic. When fired in salvos, the missiles would communicate with each other via data link, sharing targeting information and coordinating their approach to overwhelm enemy defenses. One missile in each salvo would climb to high altitude, using its radar to survey the target area and relay target positions to the others. This missile served as the coordinator for the entire attack, directing the low-flying missiles toward their targets and ensuring that multiple weapons did not waste themselves on the same ship. The remaining missiles would approach at low altitude, using terrain masking and sea-skimming flight profiles to avoid detection. They would pop up only in the final seconds before impact, giving defensive systems minimal time to react. If the high-flying missile was destroyed by enemy fire, another would automatically assume its role, climbing to altitude and taking over coordination duties. This redundancy ensured that the attack would continue, even if the defenders managed to destroy some of the incoming missiles. The swarm attack philosophy was designed to saturate the defenses of even the most capable carrier battle group, presenting so many simultaneous threats that some missiles would inevitably get through. Soviet planners calculated that even the most capable American air defense systems could not engage more than a handful of targets simultaneously, making a full salvo of 20 Granites virtually impossible to stop completely. When American analysts first understood the full implications of the Granite system, the reaction bordered on disbelief. A single Kirov-class battlecruiser could launch a coordinated attack with 20 missiles, each carrying a warhead capable of mission-killing a capital ship. The prospect of such an attack against an American carrier was deeply troubling. The Aegis cruisers then entering service could engage multiple targets simultaneously using their SPY-1 phased array radars and standard missiles, but 20 incoming missiles traveling at Mach 2.5 represented a challenge at the very edge of their capability. Computer simulations showed that even under optimal conditions, some missiles would likely penetrate the defensive screen. If even one or two got through, the damage to a carrier could be catastrophic. The Kirov's anti-ship capability alone would have made her a formidable opponent, but Soviet designers had also given her the most comprehensive air defense suite ever fitted to a surface warship. The primary system was the S-300F, the naval variant of the fearsome S-300 surface-to-air missile that had earned such respect from Western air forces. Designated SAN-6. Grumbled by NATO, this weapon system was installed in 12 vertical launch silos located forward of the bridge. Each silo contained 8 missiles ready to fire, providing a total of 96 weapons for long-range air defense. The system could engage targets at ranges up to 90 kilometers and altitudes up to 30,000 meters, creating an umbrella of protection that extended far beyond the ship herself. The S-300F used a phased array radar designated Top Dome by NATO for target acquisition and missile guidance. This radar could track hundreds of targets simultaneously and guide multiple missiles to different targets without requiring individual tracking radars for each weapon. The system represented a quantum leap over previous Soviet naval air defenses, which had relied on mechanical scanning radars with much more limited capability. With Top Dome providing continuous surveillance and tracking, the Kirov could detect incoming aircraft or missiles at extreme range and begin engaging them while they were still minutes away from weapons release. But the S-300F was just the beginning. For shorter-range threats that might leak through the outer defensive layer, the Kirov carried the 3 K-95 Kinjal system, designated SAN-9 Gauntlet by NATO. This vertically launched missile was housed in 16 8-cell modules, providing 128 ready-to-fire missiles for close-range defense. The Kinjal could engage targets at ranges up to 12 kilometers, filling the gap between the long-range S-300F and the ship's close-in weapon systems. Its response time was measured in seconds, giving it the ability to engage fast-moving anti-ship missiles in their terminal phase. The system was fully automated, capable of detecting, tracking, and engaging targets without human intervention if necessary. For point defense against missiles that penetrated even the Kinjal layer, the Kirov was fitted with 6 AK-630 close and weapon systems. Each mount featured a 6-barreled 30mm Gatling gun capable of firing between 4,000 and 5,000 rounds per minute, depending on the specific variant. Fed by a 5,000-round magazine, these weapons created a wall of steel around the ship, designed to shred incoming missiles in their final seconds of flight. The AK-630 used its own radar and infrared tracking system, allowing it to operate independently of the ship's main sensors. When an incoming missile was detected, the system would automatically slew to track the threat and open fire, its stream of 30mm shells filling the air in the missile's path. The Kirov also carried 2 OSAM missile systems, designated SAN-4 Gecko by NATO, for additional short-range air defense. Each system featured a twin arm launcher that could engage targets at ranges up to 15 kilometers. These weapons provided yet another layer of defense, backing up the more capable Kinzhal system and engaging targets that might approach from unexpected directions. The combination of long-range, medium-range, short-range, and point defense systems gave the Kirov protection against air attack that was unprecedented in naval history. An incoming strike would have to penetrate layer after layer of defenses, with each layer capable of destroying multiple attackers. American analysts tallied the numbers and reached a stunning conclusion. The Kirov carried more than 300 surface-to-air missiles, backed by close-in weapon systems of unprecedented capability. No single NATO warship came close to matching this defensive suite. The Ticonderoga class. Aegis cruisers, the most capable American surface combatants, carried 122 vertical launch cells that could accommodate a mix of weapons. Even if every cell were loaded with standard surface-to-air missiles, the total would be less than half the Kirov's anti-aircraft armament. More importantly, the Kirov's layered defense concept meant that threats would be engaged multiple times as they closed with the ship, increasing the probability that each attacker would be destroyed. Even an entire NATO surface action group, typically consisting of a cruiser and several destroyers, might not carry as many ready-to-fire missiles. The implications were profound. The Kirov could establish an air defense bubble extending nearly 100 kilometers in all directions, creating a zone of denial that would be extremely costly for any attacker to penetrate. Aircraft attempting to strike the Kirov would face long-range missiles while still far from their own weapons release points, then medium-range missiles as they closed, then short-range missiles as they approached weapons release, and finally a hail of gunfire if they managed to launch their own weapons. The cumulative probability of surviving this gauntlet was distressingly low. The Kirov's designers had not neglected anti-submarine warfare either. The ship carried extensive sensors and weapons for hunting submarines, reflecting the Soviet emphasis on protecting their ballistic missile submarines from American attack boats. Soviet doctrine recognized that their nuclear deterrent depended on the survivability of their submarine-launched ballistic missiles, and that American hunter-killer submarines posed a mortal threat to this capability. The Kirov was intended to serve as a protector for Soviet ballistic missile submarines, using her sensors to detect American attack submarines and her weapons to destroy them before they could threaten the boomers. The primary anti-submarine weapon was the RPK-6 Vodopod, designated SSN-14 Silex by NATO. 10 of these weapons were carried in quintuple launchers on either side of the superstructure, their tubes angled outward to allow rapid launch. The Silex was a rocket-propelled torpedo, capable of carrying its payload to ranges exceeding 55 kilometers, before releasing a homing torpedo or nuclear depth bomb. This standoff capability was crucial for engaging submarines that might detect the Kirov at ranges beyond conventional torpedo range. By launching the Silex toward a suspected submarine position, the Kirov could engage targets that would otherwise have time to evade or counterattack. The weapon's payload options reflected Soviet thinking about anti-submarine warfare. The conventional payload was a 400mm homing torpedo that would search for its target using active and passive sonar. If it detected a submarine, it would track and attack automatically. No further guidance from the launch ship required. The alternative payload was a nuclear depth bomb with a yield of 5 kilotons, sufficient to destroy any submarine within a radius of several hundred meters. This nuclear option was intended for use when a rapid kill was essential, such as when protecting high-value units from submarine attack. The presence of nuclear anti-submarine weapons on surface ships was particularly troubling to Western analysts, as it suggested that the Soviets might use nuclear weapons early in a naval conflict. For closer range engagements, the ship was fitted with the RBU 6000 anti-submarine rocket launcher. These 12-barreled weapons could saturate an area with RGB-60 depth charges, creating a pattern of explosions designed to destroy or damage submarines at close range. The system was reloaded automatically from a magazine below decks, allowing sustained fire against persistent submarine contacts. 2 RBU 1000 rocket launchers provided additional coverage against submarines that had closed to very short range. Their smaller charges designed to engage targets that were almost directly beneath the ship. The Kirov also carried 10 533mm torpedo tubes, capable of launching a variety of torpedoes for anti-submarine or anti-surface warfare. The ship's aviation facilities added another dimension to her anti-submarine capability. A hangar beneath the aft superstructure housed 2 K-27 Helix helicopters, equipped with dipping sonar, sonobuoys, torpedoes, and depth charges. These aircraft could extend the ship's anti-submarine search radius by hundreds of kilometers, using their sensors to detect submerged targets far beyond the range of hull-mounted sonar. When a contact was detected, the helicopter could attack directly or guide the ship's weapons onto the target. The combination of helicopter search capability and standoff weapons gave the Kirov the ability to engage submarines at ranges that would have been impossible for earlier warships. The ship's conventional armament was rounded out by a single twin 130mm gun mount forward of the bridge. This weapon, designated AK-130, used water cooling and automation to achieve a rate of fire of 20 to 35 rounds per minute per barrel. While less glamorous than the missile systems, the AK-130 was a capable weapon for shore bombardment, surface action against smaller vessels, and as a last-ditch defense against air targets. Its range of over 20 kilometers gave the Kirov the ability to engage targets beyond the horizon with the assistance of targeting data from aircraft or other ships. The gun mount was stabilized to maintain accuracy in rough seas, and its automated loading system allowed sustained fire without fatiguing the gun crews. When American intelligence compiled the complete inventory of the Kirov's weapon systems, the totals were staggering. 20 P-700 Granite anti-ship missiles, each capable of sinking an aircraft carrier. 96 S-300F long-range surface-to-air missiles with 90-kilometer range. 128 Kinzhal short-range surface-to-air missiles for close air defense. 40 OSE-M surface-to-air missiles and 2 twin-arm launchers. 10 SSN-14 anti-submarine missiles with either torpedo or nuclear payloads. 10 533mm torpedo tubes. Hundreds of anti-submarine rockets and RBU launchers. 6 AK-630 close and weapon systems with thousands of rounds of 30mm ammunition. And twin 130mm guns that could fire hundreds of rounds per minute. No single warship in history had ever carried such a diverse and powerful arsenal. The comparison with NATO forces was sobering and revealed the magnitude of the Soviet achievement. A typical American Ticonderoga-class Aegis cruiser, the most capable surface combatant in the Western inventory, carried 122 vertical launch cells that could accommodate a mix of Tomahawk cruise missiles, standard surface-to-air missiles, and ASROC anti-submarine rockets. This was impressive by any standard, but the Kirov's missile count exceeded 300. More importantly, the Granite anti-ship missiles were far larger and more powerful than anything the Americans could deploy from surface ships. The Harpoon anti-ship missile, the standard American weapon for attacking surface ships, weighed less than 700 kilograms and carried a 227-kilogram warhead. The Granite was 10 times heavier and carried a warhead more than 3 times larger. A standard NATO surface action group might consist of a Ticonderoga-class cruiser, 2 Arleigh Burke-class destroyers, and a pair of Perry-class frigates. Together, these 5 ships would carry perhaps 300 missiles of various types, roughly comparable to the Kirov's loadout. But the Kirov was a single vessel, with a single command structure and no need for the complex coordination required to manage a formation of ships. She could react faster, concentrate her firepower more effectively, and continue fighting even if damaged in ways that would cripple a distributed force. The strategic implications were obvious. A single Kirov could threaten an entire carrier battle group, forcing the Americans to devote enormous resources to countering a ship that cost a fraction of what they were spending on defense. The Kirov's propulsion system was as revolutionary as her weapons, representing Soviet engineering at its most ambitious. She was powered by 2 KN-3 pressurized water nuclear reactors, giving her essentially unlimited range at high speed. Unlike conventionally powered ships that had to periodically refuel from underway replenishment vessels, the Kirov could maintain operations for years without returning to port for fuel. Her reactor cores were designed to operate for 10 to 13 years before requiring replacement, allowing the ship to circumnavigate the globe multiple times without refueling. This endurance gave Soviet commanders strategic flexibility that conventionally powered ships simply could not match. But Soviet designers had added a unique feature that puzzled Western analysts when it was first discovered. In addition to her nuclear reactors, the Kirov was fitted with 2 conventional oil-fired boilers that could generate additional steam for the turbines. This hybrid propulsion system gave the ship an emergency backup in case of reactor problems, a not unreasonable concern given the Soviet experience with nuclear propulsion. The Soviets had lost submarines to reactor accidents and knew that nuclear power, while offering tremendous advantages, came with serious risks. The conventional boilers ensured that the Kirov could return to port under her own power, even if both reactors failed. The oil-fired boilers also provided additional power for high-speed dashes when pursuing or evading an enemy. Under normal cruising conditions, the nuclear reactors alone could propel the ship at speeds up to 24 knots. When the boilers were lit, the combined power plant could push the Kirov to over 32 knots, fast enough to outrun many of the submarines and surface ships that might threaten her. This burst speed capability was valuable for closing to missile range against a fleeing enemy or for opening the range against superior forces. The combination of nuclear endurance and conventional sprint power gave the Kirov tactical flexibility that no previous warship had possessed. The speed and endurance provided by this propulsion system made the Kirov a true blue water combatant, capable of operating anywhere in the world's oceans. Soviet strategy called for these ships to lead surface action groups into the Atlantic and Pacific, threatening NATO sea lanes and forcing the Western Alliance to divert resources from other missions. In the Atlantic, the Kirov would operate in conjunction with submarines and maritime patrol aircraft to interdict the reinforcement convoys that would be essential for NATO to sustain combat in Europe. In the Pacific, she would threaten American bases in Japan and the Philippines, forcing the United States to dilute its forces across multiple theaters. In wartime, the Kirov would serve as the nucleus of a hunting group specifically designed to locate and destroy American aircraft carriers. This force might include Slava-class cruisers, Sovremenny-class destroyers, and nuclear attack submarines, all coordinated by the Kirov's extensive command and control facilities. Protected by her formidable air defense suite, the Kirov would close to granite range and launch a devastating salvo that could potentially kill a supercarrier with a single hit. The escorts would add their own missiles to the attack, creating a wave of destruction that even the most capable carrier battle group would struggle to survive. The construction program called for 4 ships of the class, each incorporating improvements based on lessons learned from earlier hulls. The second ship, Frunze, was commissioned in 1984. She featured enhanced sensors and command systems, reflecting the rapid pace of Soviet electronic development during the early 1980s. The Combat Information Center was larger and more capable, allowing the ship to coordinate the operations of multiple other vessels in addition to managing her own weapons. The radar systems were updated versions with improved range and target discrimination capability. The electronic warfare suite was expanded to provide better warning of incoming missiles and better jamming capability against enemy targeting systems. The third ship, Kalinin, joined the fleet in 1988 with further improvements to her air defense systems. The most significant change was an upgraded version of the Kinjal short-range missile system, with improved seekers that could engage more challenging targets, including sea-skimming missiles. The electronic countermeasures suite was again improved, incorporating lessons learned from the limited combat experience Soviet ships had accumulated during deployments to various global hotspots. Kalinin also featured enhanced habitability for her crew, with improved living quarters and recreational facilities that recognized the reality that modern warships spend months at sea without port visits. The fourth and final vessel, Yuri Andropov, was commissioned in 1998, years after the collapse of the Soviet Union that had ordered her construction. By this time, she had been renamed Pyotr Veliky, or Peter the Great, reflecting the new Russian government's desire to distance itself from Soviet symbolism. Her construction had been delayed repeatedly by the economic chaos that followed the end of the Cold War, and she was completed with a weapons suite that was significantly different from her sisters. The most notable addition was the Kinjal anti-submarine missile system, which replaced the OSA-M short-range air defense weapons. This change reflected the Russian Navy's evolving tactical thinking and the availability of newer weapon systems. The American response to the Kirov threat was multifaceted, addressing the challenge at every level from tactics to strategy to technology. The Navy accelerated development of longer-range anti-ship missiles, recognizing that the only way to safely engage a Kirov was from beyond the range of her own weapons. The Tomahawk anti-ship missile variant was designed to engage surface targets at ranges exceeding 450 kilometers, allowing launch platforms to strike from beyond the Granite's maximum reach. This weapon used terrain following flight profiles and advanced seekers to penetrate enemy defenses, though it was smaller and slower than its Soviet counterpart. Submarine-launched weapons became increasingly important in American planning as attack submarines could approach the Kirov unseen and launch devastating attacks from unexpected quarters. The submarine-launched Harpoon provided a standoff capability that allowed American boats to strike without closing to torpedo range. The Mk-48 torpedo was upgraded with improved seekers and longer range, giving it a better chance of reaching a fast-moving target like the Kirov. Most importantly, submarine tacticians developed approach profiles designed to exploit the Kirov's relative vulnerability to underwater attack. Her anti-submarine weapons were formidable, but they required that she first detect the attacking submarine, a task made more difficult by the increasing quietness of American boats. The Harpoon missile itself was upgraded with improved seekers and electronic countermeasures, though it remained significantly smaller than the Granite. American planners recognized that a single Harpoon hit might not be sufficient to kill a ship as large and well-protected as the Kirov, so tactics emphasized saturation attacks using multiple launch platforms. A strike against a Kirov surface action group might involve aircraft from multiple carriers, surface ships firing from dispersed positions, and submarines attacking from below, all coordinating their weapons release to overwhelm the target's defenses. Plans were drawn up for a new generation of surface combatants that could match the Soviet building program, though budget constraints would limit what could actually be constructed. The Arsenal ship concept, which envisioned a large vessel carrying hundreds of vertical launch cells, was studied but never built. The limitations of existing hull designs became apparent as planners tried to cram more weapons onto ships that were not designed to accommodate them. The American response would ultimately rely on the combination of carrier aviation, submarine attack, and coordinated surface forces, rather than on matching the Kirov ton for ton. Perhaps the most significant American response was doctrinal rather than technological. Navy planners concluded that surface action groups alone could not safely engage a Kirov and her escorts without suffering unacceptable losses. The solution was to integrate carrier aviation more closely with surface forces, using aircraft to deliver strikes against Soviet ships before they could close to Granite range. F-14. Tomcats, armed with Phoenix missiles, would engage Soviet aircraft, providing targeting data, blinding the enemy reconnaissance effort, and denying them the information they needed to coordinate an attack. Meanwhile, A-6 Intruders and later F-A-18 Hornets would deliver Harpoon missiles and laser-guided bombs against the ships themselves. This combined arms approach would become the foundation of American naval strategy for the remainder of the Cold War. Intelligence collection against the Kirov class became a top priority for American and NATO forces, consuming enormous resources and generating vast amounts of data. Attack submarines were assigned to shadow Soviet surface groups whenever they left port, gathering acoustic signatures that could be used to identify and track the ships. These submarines would trail the Kirov for days or weeks at a time, recording every sound she made and observing her tactical evolutions. The data they collected was invaluable for developing tactics and training crews who might someday have to engage these vessels in combat. Reconnaissance aircraft made regular flights along the Soviet coastline, photographing the ships and collecting electronic intelligence on their radar and communication systems. P-3. Orion maritime patrol aircraft would probe the edges of Soviet fleet exercises, testing their air defenses and observing their responses. When a Kirov left port, American reconnaissance assets would track her movements, noting her speed, course, and any tactical maneuver she performed. This information was fed back to intelligence analysts, who built ever more detailed pictures of Soviet capabilities and intentions. Agents within the Soviet Union provided details on construction progress, crew training, and operational capabilities that could not be obtained through technical means. These human sources, often motivated by ideology or personal grievances, risked their lives to pass information to Western handlers. Some provided technical documents describing weapon systems in detail. Others reported on crew morale and training standards. Still others described the problems and deficiencies that plagued the Soviet naval program, information that helped American planners understand the limitations as well as the capabilities of their adversaries. Gradually, the West assembled a comprehensive picture of the Kirov and her sisters, identifying both their strengths and their potential weaknesses. One weakness that emerged from this intelligence effort was the Kirov's complexity. With so many weapon systems and sensors packed into a single hull, the ship required an enormous crew to operate effectively. Nearly 700 officers and sailors manned each vessel, compared to perhaps 350 on an American Aegis cruiser. This crew included specialists for each of the major weapon systems, electronics technicians to maintain the sophisticated radars and computers, and the nuclear-trained personnel required to operate the ship's power plant. Manning such a vessel was a significant challenge for the Soviet Navy, which was already stretched thin by its ambitious building programs. The Soviet conscript system meant that many of these sailors were poorly trained draftees who served only 2 or 3 years before returning to civilian life. Unlike American sailors who volunteered for service and often served for 20 years or more, Soviet conscripts had little time to master the complex systems they were expected to operate. Training programs tried to compress years of learning into months, with predictably imperfect results. Western observers noted that Soviet crews often struggled with routine operations that would be second nature to their American counterparts. Equipment that American sailors maintained meticulously was allowed to deteriorate on Soviet ships, reducing combat capability and increasing the risk of catastrophic failure. Another potential weakness was logistical. The Kirov's nuclear reactors gave her unlimited range, but her weapons had to be replenished after use. The P-700 Granite missiles, in particular, could only be loaded in port using specialized equipment that was available at only a handful of Soviet naval bases. The missiles were so large and heavy that they could not be transferred at sea from replenishment ships, a significant limitation for a vessel intended to operate far from home waters. Once the Kirov had expended her main armament, she would have to return to a friendly port for rearmament, a journey that could take weeks depending on her location. In contrast, American ships could replenish at sea from underway replenishment vessels, allowing them to sustain operations far from their home bases. This capability had been developed over decades of operating carrier battle groups across the world's oceans, and it gave American forces a significant advantage in extended operations. The Kirov might win the first battle, but if the war continued, she would eventually have to withdraw to reload while American forces continued to operate. Soviet planners were aware of this limitation and designed their strategies accordingly, but it remained a fundamental constraint on how the Kirov could be employed. Despite these limitations, the Kirov class represented a genuine threat to NATO naval superiority that could not be dismissed or ignored. War games and exercises consistently showed that a well-handled Kirov could inflict severe damage on a carrier battle group before being neutralized. The combination of massive firepower, robust defenses, and high speed made her an extremely difficult target to engage successfully. American planners concluded that neutralizing a Kirov would likely require a coordinated attack by carrier aircraft, submarines, and surface ships, all striking simultaneously from different directions to overwhelm her defenses. The cost in aircraft and lives would be significant, but the alternative was allowing the Soviet ship to savage the fleet with impunity. The geopolitical implications of the Kirov program extended far beyond the tactical level and influenced how nations around the world perceived the superpower competition. The ships represented the pinnacle of Soviet naval power, tangible symbols of the USSR's claim to superpower status. When a Kirov visited foreign ports, she demonstrated Soviet capabilities to potential allies and adversaries alike. The sight of this massive warship with her bristling armament made a powerful impression, suggesting that the Soviet Union was capable of projecting power anywhere in the world. For nations considering alignment with Moscow, the Kirov was evidence that the Soviets could protect their friends and punish their enemies. The psychological impact on Western sailors should not be underestimated, particularly among those who would have to face the Kirov in combat if the Cold War turned hot. For officers and enlisted men who would have to fight this ship, the prospect was daunting. Training exercises attempted to simulate engagements with Soviet surface groups, but the sheer volume of simulated missile fire often overwhelmed defensive systems designed to protect against more modest attacks. Young sailors watched training videos that showed the Granite missile streaking toward its target at 2.5 times the speed of sound, knowing that their lives might depend on stopping such a weapon. The Kirov became something of a bogeyman in NATO navies, a worst-case scenario against which all defensive measures were tested and often found wanting. In the intelligence community, the Kirov became a case study in how the Soviet Union approached military technology. Rather than developing systems incrementally as the West tended to do, Soviet designers were willing to make dramatic leaps, accepting greater technical risk in pursuit of revolutionary capabilities. The Kirov embodied this philosophy perfectly. She was not an evolution of previous cruiser designs, but something entirely new, a warship that combined capabilities that Western navies distributed across multiple vessel types. This willingness to take risks meant that Soviet systems sometimes failed spectacularly, but when they worked, the results could be remarkable. The analytical methods used to assess the Kirov's capabilities would influence how American intelligence evaluated threats for decades to come. Specialists developed new techniques for estimating missile performance from observations of test flights, for predicting radar capabilities from antenna dimensions, and for assessing ship vulnerability from structural analysis. The lessons learned from studying the Kirov were applied to subsequent Soviet and Russian military developments, creating a body of knowledge that would prove invaluable as the Cold War gave way to a new era of great power competition. The end of the Soviet Union in 1991 threw the future of the Kirov class into doubt, as the Russian Federation that inherited these ships lacked the resources to maintain them properly. The Soviet economy had been able to support an ambitious naval construction program, but the chaos that followed the USSR's dissolution left Russia struggling to feed its population, let alone maintain nuclear-powered battlecruisers. Budgets that had once funded new construction were redirected to basic maintenance, and even that proved insufficient to keep the fleet operational. The Kirov herself was decommissioned in 1990, her nuclear reactors having reached the end of their designed service life. Refueling nuclear reactors was a complex and expensive operation that required specialized facilities and trained personnel, resources that the struggling Russian Navy could not afford. The ship was laid up at Severodvinsk, her weapons removed and her crew dispersed to other assignments. She remains there today, rusting slowly as debates continue about whether to scrap her or attempt an impossibly expensive restoration. The Frunze, renamed Admiral Lazarev, followed in 1999 after years of increasingly sporadic operations. Like her sister, she'd suffered from inadequate maintenance during the chaotic post-Soviet years, and her material condition had deteriorated to the point where continued operation was no longer practical. She was laid up alongside the Kirov, two monuments to Soviet ambition slowly decaying in the harsh northern climate. Plans to restore her have been discussed periodically, but the estimated costs have always proven prohibitive for a nation struggling to maintain even basic naval capabilities. The Kalinin, renamed Admiral Nakhimov, followed in 2002, leaving only the Pyotr Veliki in operational service. Even she has spent extended periods in repair yards, her systems aging and increasingly difficult to maintain as the supply chains that once produced spare parts have withered. The dream of a fleet of nuclear-powered battle cruisers roaming the world's oceans has given way to the reality of rusting hulls and empty slipways. The Russian Navy today operates a fraction of the Soviet fleet, and even that reduced force struggles with readiness issues that would have been unthinkable during the Cold War. Efforts to modernize and return the decommissioned ships to service have been plagued by delays and cost overruns that reflect the broader challenges facing the Russian defense industry. The Admiral Nakhimov has been under refit since 2014, with completion dates repeatedly pushed back as work proceeds at a glacial pace. When she finally emerges, she will feature updated weapon systems, including the hypersonic Zircon missile, potentially restoring some of the threat that the Kirov class once posed. But questions remain about Russia's ability to maintain such complex vessels, given its economic constraints and the erosion of technical expertise that has occurred since Soviet times. For Western analysts who spent their careers studying the Kirov class, the ships remain objects of professional admiration even as they rust into oblivion. Whatever the political system that created them, the Kirovs represented genuine technical achievement that pushed the boundaries of what was possible in naval engineering. Soviet engineers had solved immense challenges in integrating so many weapon systems onto a single platform, in developing the cooperative attack logic that made the Granite so deadly, and in creating a vessel that could operate independently for months on end. The solutions they found were often different from those chosen by Western designers, reflecting a distinct engineering culture and different tactical priorities, but they worked. The legacy of the Kirov class extends beyond the ships themselves and continues to influence naval warfare today. The threat they posed drove development of the Aegis combat system, the Standard missile family, and countless other defensive technologies that remain in service. The tactics developed to counter them influenced how navies around the world think about anti-surface warfare. The intelligence techniques pioneered to assess their capabilities became standard practice for evaluating military systems. In a very real sense, the Kirovs shaped the modern naval environment, even as they themselves have faded into obsolescence. The story of the Kirov and how American analysts came to understand her capabilities is ultimately a story about the Cold War itself. It illustrates how two superpowers devoted enormous resources to competing for maritime supremacy, how each side studied the other with obsessive intensity, and how the fear of nuclear annihilation drove technological innovation at a furious pace. The men who designed and built the Kirov believed they were creating a weapon that would help defend their nation and advance their ideology. The analysts who studied her believed they were protecting the free world from a mortal threat. Both were products of their time, caught up in a rivalry that defined the second half of the 20th century. Today, the surviving Kirov-class ships are relics of a vanished era. The Pyotr Veliki still puts to sea occasionally, a massive gray presence that recalls the days when Soviet naval power seemed poised to challenge American dominance. The others rust at anchor or await decisions about their ultimate fate that may never come. The crews who manned them have aged, their experiences fading into history along with the Cold War itself. But the lessons of the Kirov remain relevant. The ship demonstrated what is possible when a nation commits to building the most powerful warship it can imagine, regardless of cost or convention. That lesson has not been lost on today's naval powers. The detailed analysis conducted by American intelligence on the Kirov class provided crucial insights that influenced decades of naval policy and weapons development. Studying the ship's radar signatures allowed electronic warfare specialists to develop jamming techniques that might blind her sensors in combat. Assessing her structural design helped weapons engineers optimize warhead placement for maximum damage against similar vessels. Understanding her command and control architecture revealed potential vulnerabilities that could be exploited in combat. Every piece of information, no matter how small, contributed to a picture that helped naval commanders understand what they would face if the Cold War turned hot. The men and women who conducted this analysis deserve recognition for their contribution to Western security, even if their names remain classified. Working in facilities around the world, they pored over satellite imagery, analyzed intercepted communications, debriefed defectors, and synthesized information from countless sources. Their work was often tedious and always secret, but it provided decision-makers with the knowledge they needed to respond appropriately to Soviet naval developments. Without their efforts, the West might have been surprised by the Kirov's capabilities, with potentially catastrophic consequences for the balance of power. The story of the Kirov is also a reminder of how quickly military technology can change and how today's revolutionary system becomes tomorrow's obsolete relic. The ship that seemed so revolutionary in 1980 looks almost primitive compared to modern naval systems. Her phased array radars, so advanced for their time, have been superseded by systems with far greater capability. Her missiles, while still formidable, face defenses that did not exist when they were designed. Even her nuclear propulsion, which gave her such strategic flexibility, has been matched or exceeded by other navies. Military advantage is fleeting, a lesson that today's naval planners would do well to remember. As we look back at the Kirov from the perspective of nearly half a century, certain truths become clear. The ship was a product of a specific time and place, designed to address threats and fulfill missions that seemed pressing in the 1970s and 80s. She embodied the Soviet approach to naval warfare, emphasizing firepower and survivability over the power projection capabilities that Western navies favored. Her existence forced NATO to develop new weapons and tactics, driving innovation that might not have occurred otherwise. In this sense, even though the Kirov never fired her weapons in anger, she influenced the course of military history. The analysts who first studied the Kirov and realized the magnitude of the threat she posed were confronting something genuinely new. Nothing in their experience had prepared them for a surface combatant with such overwhelming firepower, packed into a single hull. Their task was to understand this vessel well enough to advise policymakers on how to respond, a responsibility that carried enormous weight given the stakes involved. They rose to the challenge, producing assessments that remain classified decades later, but that shaped American naval policy throughout the final years of the Cold War. The title of this account refers to the moment when those analysts completed their initial assessment and realized that a single Soviet ship carried more firepower than an entire NATO squadron. This was not hyperbole or propaganda, but a sober technical conclusion based on careful analysis of observable evidence. The Kirov's 300-plus missiles, her layered defenses, her nuclear propulsion, and her sophisticated sensors combined to create a platform of unprecedented capability. Recognizing this fact was the first step in developing an effective response, a process that would consume the attention of naval strategists for years to come. Some might argue that the threat was overstated, that the Kirov's complexity made her unreliable, or that Soviet crews could never have operated her effectively in combat. These criticisms have merit, and intelligence assessments at the time acknowledged the Kirov's limitations alongside her capabilities. But military planning must account for the possibility that an adversary will perform at their best, not their worst. Assuming that the Kirov would fail due to technical problems or crew errors would have been irresponsible and potentially catastrophic. The prudent course was to prepare for the worst while hoping for the best. The rivalry between Soviet and American naval forces during the Cold War produced some of the most sophisticated military technology in human history. The Kirov was part of this competition, a Soviet response to American carrier power that forced the West to develop new capabilities of its own. This action and reaction dynamic drove innovation on both sides, producing advances that eventually found their way into civilian applications. Radar, satellite communications, nuclear power, and countless other technologies were accelerated by the need to maintain military advantage. The price was enormous, both in treasure and in the ever-present risk of nuclear war, but the technological legacy remains. Understanding the Kirov and her significance requires placing her in the context of Cold War naval strategy. The Soviet Navy was never designed to control the seas in the way the American Navy was. Instead, Soviet planners focused on denying the seas to their adversaries, preventing American carrier groups from operating freely in waters that mattered to Soviet interests. The Kirov was the ultimate expression of this sea denial philosophy, a ship designed to force American carriers to keep their distance and to exact a terrible price if they ventured too close. She was not meant to win a naval war single-handedly, but to make such a war too costly for the Americans to contemplate. This strategic perspective helps explain why the Soviets invested so heavily in anti-ship missiles while neglecting other aspects of naval power. They did not need to project power ashore when they had the world's largest army already positioned in Europe. They did not need to protect sea lanes when most of their trade moved overland. What they needed was the ability to threaten American power projection, to neutralize the carriers that would otherwise support NATO ground forces in any European conflict. The Kirov and her missiles were the answer to this strategic requirement. The intelligence community's assessment of the Kirov was not just a technical exercise, but a strategic one as well. Analysts had to understand not only what the ship could do, but what the Soviets intended to do with her. This required studying Soviet naval doctrine, observing exercises and deployments, and interpreting statements by Soviet officials. The picture that emerged was one of a Navy increasingly confident in its ability to challenge American supremacy, at least in certain scenarios. The Kirov was evidence that the Soviets were serious about this challenge, willing to invest vast resources in platforms that could genuinely threaten American naval power. The passage of time has allowed for a more balanced assessment of the Kirov's significance. She was indeed a formidable warship, but she was not invincible. American submarines could approach unseen and deliver devastating attacks with torpedoes or cruise missiles. Carrier aircraft could strike from beyond granite range, using standoff weapons to avoid the Kirov's defenses. The ship's complexity meant that systems would inevitably fail, potentially at critical moments. And the Soviet crew training and maintenance practices meant that the ship rarely operated at full theoretical capability. These factors, understood by Western analysts at the time, meant that the Kirov was a serious threat but not an insurmountable one. The real significance of the Kirov may lie not in her combat capability, but in what she represented. She was proof that the Soviet Union could build sophisticated military systems that matched or exceeded Western capabilities in certain respects. She demonstrated that Soviet engineers could solve immense technical challenges when given sufficient resources and priority. She showed that the Cold War competition was genuinely competitive, that American superiority could not be taken for granted. These lessons were sobering for those who assumed that Western technology would always be superior, and they remain relevant today. The analysts who studied the Kirov and documented her capabilities were performing a vital service for their nations. Their work informed policy decisions that affected billions of dollars in military spending and the lives of millions of service members. The assessments they produced shaped naval construction programs, drove weapons development, and influenced strategic planning at the highest levels. Though their names remain classified, their contribution to Western security was immense. They exemplified the best traditions of the intelligence profession, combining technical expertise with strategic insight to provide decision-makers with the knowledge they needed. As the Cold War recedes further into history, the Kirov-class ships become museum pieces, reminders of an era when two superpowers stood poised to destroy each other. The lessons they taught about naval warfare, intelligence analysis, and great power competition remain relevant. New challengers have emerged, building their own sophisticated warships designed to challenge American naval supremacy. The methods pioneered to assess the Kirov are being applied to these new threats, as a new generation of analysts works to understand capabilities that their adversaries would prefer to keep secret. The cycle continues, driven by the same dynamics that produced the most heavily armed surface combatant ever to sail the world's oceans. The final chapter of the Kirov story has yet to be written. Russia still harbors ambitions to restore its fleet of nuclear battlecruisers, though economic reality may prevent this dream from being realized. The Admiral Nakhimov may eventually emerge from her long refit, equipped with modern weapons that could once again threaten Western naval forces. Or she may join her sisters in the scrapyard, a monument to Soviet ambition and Russian decline. Whatever happens, the Kirov-class ships will be remembered as remarkable achievements of naval engineering, vessels that changed how the world's navies thought about surface warfare. They earned their place in history not through combat, but through the profound impact they had on naval strategy, weapons development, and intelligence analysis during the most dangerous decades of the nuclear age. The story of when American analysts studied the Kirov's arsenal and found more firepower than an entire NATO squadron is ultimately a story about the Cold War at sea. It speaks to the fears and ambitions of both superpowers, to the technological achievements and strategic calculations that characterized the era, and to the men and women who devoted their careers to understanding an adversary that could never be directly confronted. Their work helped prevent the war that both sides feared, maintaining the uneasy peace that allowed the Cold War to end without nuclear catastrophe. In that sense, the analysts who first documented the Kirov's terrifying arsenal were not just observers of history, but participants in it. Their careful assessments helping to ensure that the most powerful warship ever built would never fire her weapons in anger. That is a legacy worth remembering, even as the ships themselves rust into oblivion and the Cold War passes from memory into history.